To solve this polynomial inequality, we need to factor the left-hand side by grouping. We don't need to move anything because our left-hand side and 0 is by itself. So if we factor by grouping, we have x squared. We took out an x squared from the first two terms, leaving us with x plus 1. And the last two terms have a 4 in common, also leaving us with x plus 1. Now we can group these together. We have x plus 1 times x squared plus 4 is greater than or equal to 0. To find our test points, set each part equal to 0 and solve for x. We have x plus 1 is equal to 0 and x squared plus 4 equal to 0. First equation, our test point is negative 1. Second part, second equation, we subtract 4 from both sides. So we have x squared equal negative 4. To solve for x, you know to take the square root of both sides. You know that a negative inside the radical, inside of a square root, becomes an imaginary number. So therefore, we do not have a real number for the second part. So our only test point is x equal to negative 1. Next step, put negative 1 on your number line. And we need to find numbers to test the interval both less than negative 1 and also the interval greater than negative 1. So what would you like to pick for less than negative 1? Negative 2 is a good choice. Negative 3 would be fine. Anything less than negative 1 would work. And the obvious choice for greater than negative 1 would be 0. Let's test negative 2 first of all. And we're going to use the factored inequality, x plus 1 times x squared plus 4. And we're trying to verify if that comes out true or false based on our test point. So we'll plug in negative 2. This will give you negative 1 times 4 plus 4. Which will leave us with negative 1 times 8. We have negative 8 is greater than or equal to 0. Is this true or false? Right, this is definitely false. So anything less than negative 1 will not be a part of our solution. Now, let's test x equals 0. Again, using the factored inequality. Everywhere you see an x, plug in plug in 0. So we have 1 times 4 which will give us 4 is greater than or equal to 0. Yes, this is a true statement. So our solution would be everything greater than or equal to negative 1. We can go ahead and, on our number line, shade our solution. Now, since you're given less than or equal to or greater than or equal to, then you need to use brackets. The only time you would probably not use brackets is if you had a fraction or a radical that would make the denominator 0 or maybe undefined. But here we can use brackets. And shade everything greater than negative 1. Our solution set is brackets negative 1 to infinity. In the next video, we will discuss how to solve a rational inequality.